Okay, this video is going to take us through lesson 2.4, which is solving equations with variables on both sides now. So if we look here, we've got an x on one side and then an x on the other side. All right, so starting with example A here, I'm going to continue to draw my wall just like I've been doing. Now, when we are looking at this, we need to first step here, get those x's on the same side. And it doesn't matter which one you move. If you want to subtract the 5x and bring it over to this side, that's okay. And then if you want to subtract the 2x and bring it over to the side, that works too. All right, so I'm going to go ahead and just subtract the 2x over to the other side. So those will cancel. So I have 3x plus 2 equals 14. I'm going to subtract 2 now from both sides and get 3x equals 12. And then I'm going to divide both sides by 3. So x equals 4. And that's going to be my final solution. All right, so going to part B here. All right, so it's the same thing. Again, I'm going to draw my wall. It doesn't matter which one you choose to move. So like on this time, I'm going to go ahead and just move this guy over to here. But could we add 4k and bring it over here? Absolutely. So I'm going to go ahead and add 7k over to the other side. So those will cancel. Oh, wrong one. How about these will cancel? So I get 2 equals 3k minus 10. And now I'm going to add 10 to both sides because, again, we got to isolate that k. 12 equals 3k. And so when I divide by 3, I end up with 4 equals k. And that's going to be my final answer there. Okay, let's go ahead and look at C. Now on C, in this case, we're going to have to distribute first. So remember, our rules of distributing and combining like terms are still in play. All right, so I'm going to go ahead and distribute the 7 first and get 28 minus 7a. And then I'm going to distribute the 3 through and get 3a minus 12. Make sure we distribute to both those parts. Now I'm going to draw my wall. And again, it doesn't matter which a I move first. I can either add the 7 over to this side, or I can subtract the 3 and bring it over this way. Again, doesn't matter which one you move first. So I'm going to add the 7a over to the right-hand side. Those are going to cancel. So 28 equals 10a minus 12. Now I'm going to add 12 to both sides and get 40 equals 10a. My last step is to divide both sides by 10. So 4 equals a. All right, let's go to D. All right, so again, keep in mind, we distribute, we combine like terms, and then we solve. Same 3 steps that we've been learning in our previous lessons. So we're going to start by distributing. Now let's make sure, though, that we distribute that negative 2, right? Take the negative along. So I'm going to distribute that negative 2 through and get 8 minus 2a minus 2, right? Negative 2 times 1 is negative 2, equals 9 plus a. So I've distributed. Now, before I do anything moving things side to side, I'm going to combine like terms. I'm going to put the 8 and the negative 2 together. So I'm going to get negative 2a. 8 minus 2 is positive 6 equals 9 plus a. Okay, so now that I've done my first 2 steps, now that I've distributed, now that I've combined like terms, now I'm going to move side to side, okay? And again, I can either add the 2a over, or I can subtract this. Remember, it's a 1, right? Subtract this 1a over to the other side. It doesn't matter which way. So in this case, I'm going to add the 2a over. So those cancel, so I get 6 equals 9 plus 3a. Now I'm going to subtract that 9 off to get that a isolated. So I get negative 3, extend my line here a little bit, equals 3a. And I'm going to divide by 3 on both sides. So negative 1 equals a. Okay. All right, we are going to skip D and E for now. I want you to go ahead and flip to the second side here, and let's look at this E. All right, so we're going to distribute, right? First thing we always do is distribute to both parts. So I have got 10x plus 12 equals 10x plus 12. Okay, now I need to get the x's on the same side, right? So I'm going to subtract 10x. And when I look here, something funky kind of happens. They both cancel out. So I get 12 equals 12. Okay, so when this happens and the variable falls off and you have like 12 equals 12, this is called all real numbers. Okay, and all real numbers mean that any number I put in up here will work. So if I want to put a 1 here and a 1 here, great. If I want to put negative 100 and negative 100, it'll work. If I want to put 1/2 and 1/2, it'll work. You'll get the same answer. Okay, now there is a symbol for all reals. So think of it, it's kind of like 2 lines and then an extended R. So that will be the symbol for all real numbers. Okay, so when it's exactly the same on both sides, like it is here, okay, that's all reals. Now, some of you guys, though, might have noticed way back here. See how they're the same on both sides? We get 10x plus 12 and 10x plus 12. So if you notice it way back here, you can bypass all of this and go straight to all real numbers. Okay, so it doesn't matter at what point you see they're identical. Once you know they're identical, this is going to be your answer. Okay, all right, let's look at the next one here. All right, so just like we've been talking about, we distribute, which there's no distributing here. So now combine like terms. So put negative 3m and 12m together first. So I have 9m minus 4 equals negative 3 plus 12 is 9. So I get 9m plus 5. Okay. Now I'm going to subtract my 9m over to the other side here, and those are going to cancel. Okay, so it's kind of like what happened on the last problem, except we've got a negative 4 on this side and a 5 on that right-hand side. So it's a little different than the previous one, because here it was exactly the same on both sides, which tells us all numbers work, but here, it's not the same on both sides. So when it's not, I don't know how I did that. When it's not the same on both sides, that's going to be a no solution. Now the symbol for no solution is 0 with a slash through it. Okay? And so what that is telling us is no answers will work. It doesn't matter what I put in up here, nothing will ever equal each other. Okay? So my answer is no solution. All right, so let's take a look here. Last problem. So we're going to go through our 4 steps for working on a word problem, right? We're going to define a variable, write an equation and solve, and then we're going to write our sentence. Okay? It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours. But it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? All right, so first off, right, define our variable. What are we looking for? Well, we're looking for how many web pages. Okay, so I'm going to go ahead and put like W for amount or number of web pages. Okay. All right, so now we've got 2 ideas here that we need to look at. We have got it takes 1.5 hours, or they can get this new software where it only takes 1.25 hours, but they've got 8 hours kind of a training at first. Okay, so when I'm looking at this, if it's 1.5 hours to make a page, I'm going to make that 1.5 W. So it's 1.5 hours for every web page I make. Or, set equal, the other option I have is it's going to be 1.25 hours to make a web page, but I've got to put in 8 hours up front. Okay, so now we're going to solve our equation. And I'm going to start by drawing my wall. Now again, we've got to get the W's on the same side. Now in this case, you are going to want to move this 1.25 over to this side. Okay, so I'm going to subtract the 1.25W from both sides. So that cancels. So I get 1.25W equals 8. All right, now I'm going to divide by 1.25 and get W equals 6.4. All right, so now write your sentence. So at 6.4 web pages, we'll see, we'll put both methods are equal. Okay, all right, that concludes these notes.